Okay, so we have studied about non-electrical methods of temperature measurement, in which we have studied bimetallic strip, and the another one is liquid in glass thermometer. You have commonly seen this liquid in glass thermometer because it is one of the most common type of temperature measuring device, and this temperature measuring instrument consists of a glass envelope, which has a glass envelope, and at the bottom it contains a temperature sensing bulb. In this bulb, we filled with a gas, and in this stem, there is a marking, that is an indicating scale. So, the glass envelope consists of a small bore graduated glass tube with a small bulb which containing the corresponding liquid. Okay, that liquid filled on this glass tube is a temperature sensitive liquid. That means if we change the temperature, it will expand through this temperature step. Okay, so this type of thermometer, in this type of thermometer, the liquid will expand with the increase in temperature. So when there is a change in temperature, the liquid contained in this glass tube will expand to the this capillary tube. So it will the change in level of this change in expansion level of this liquid will give a corresponding reading on this graduated scale, which is the measure of temperature. Okay, and you can see this is a liquid in glass thermometer. Constructionally, it is a glass tube in which at the bottom you can see a bulb which will contain the liquid to be expanded, and there is a small thin stem inside the glass tube. Okay, so this bulb will be bulb of the thermometer is a thin glass reservoir which is filled with a um, that liquid to be expanded, temperature sensitive liquid. Okay, so the narrow stem contain a graduated scale on this glass tube, and when the temperature increases, this thermometer liquid will expand to a particular level. So this portion is bulb. Okay, this portion is a bulb, and this side which contain the liquid, and this narrow, you can see a narrow line inside this glass tube, that is a narrow expansion region of this tube. Okay, and which contain an auxiliary scale. Here you can see a graduated scale before this main scale. That auxiliary scale is used for just measuring that means ice point of that temperature, that means 0 point of temperature, to measure or calibrate the temperature range of this thermometer. We use this graduated scale, that is auxiliary scale, and you can see a small uh, area which increases the stem area, that is known as meniscus. Okay, here you can see the auxiliary scale is a short scale with a graduation to check for the ice point reference. To calibration purpose only we use this auxiliary scale because the scale is before the main scale. And this chamber is known as contraction chamber. Here the area of the stem increases. If we want to decrease the length of this thermometer, in before the main scale we made some one or more contraction chamber, so we can reduce the total length of this thermometer by providing a contraction chamber before the main scale. We can reduce the length of this thermometer because here the area this stem area will be increased on this contraction chamber. So on a particular increase in temperature, that liquid can be expanded to fill this chamber, and then it is a narrow length. So this contraction chamber is usually provided before the main scale area. And there is an expansion chamber at the top of the thermometer. That expansion chamber is provided to protect the thermometer glass tube because when we put our this thermometer on a high temperature medium, which can withstand. That means the liquid inside this thermometer can be expanded to the top of the scale. When it increases up to this range, what happens? It will be there is a tendency to break this glass tube due to higher pressure. So to provide to build up or to prevent that build up or increase in pressure, we are providing this expansion chamber. So it's a protection chamber for the thermometer from the higher increasing pressure of the liquid. Okay, and there are three types of thermometers according to the usage. That means total immersion thermometer, partial immersion thermometer, and complete immersion thermometer. You can see total immersion thermometer. This one is a total immersion thermometer in which the calibrated scale which can read correctly when the thermometer is immersed, so that the top of the mercury column is the level with the liquid surface. So the mercury column is totally immersed on the liquid whose temperature is to be measured. And partial immersion thermometer means we can put only a specified portion of the thermometer to the medium. That means there will be a marking on that thermometer. We we need only to immerse up to that marking. And another one is complete immersion thermometer. For that calibrate or to read that thermometer, we have to immerse it fully to the medium, test medium. Okay. So you can see usually like this, it's a partial immersion thermometer. Here you can see a marking, that is the immersion line. So the depth of the thermometer should be immersed as up to this. So you have to immerse this much portion of the thermometer in the medium whose temperature is to be measured. Okay, so this is the bottom portion bulb. So the narrow stem is provided here and the immersion line is here. So you have to immerse this thermometer up to this portion in the medium whose temperature is to be measured. Okay, and these are the liquid in metal thermometers. Okay, so the next one is, I will explain. So we have to study only non-electrical methods, that is bimetallic thermometer and liquid in glass thermometer. These are the two non-electrical methods of measurement of temperature measurement. And the next one is, I will explain the next one. Okay. 1 second, I will share the screen. Next, we have to study temperature measurement by electrical means. We have already told temperature measuring instruments are of 4 types. First one is non-electrical method. In non-electrical method, there are solid, which is temperature is measured by solid or liquid or gas expansion method. By using gas expansion method or liquid expansion method, we studied about the thermometers, and solid expansion method is bimetallic thermometer. So we have studied this non-electrical method. Now we have to study electrical methods of temperature measurement. That is first one, thermoelectric sensors, thermocouples. So thermocouples usually we can see like this. So this is the main thermocouple which is to be which we need to contact with the medium whose temperature is to be measured. So it is known as thermocouple. Okay. So thermocouple, I will explain thermocouple working principle. Mainly it is constructed by using two wires, two metallic wires, but they are different metals. So thermoelectric sensors or thermocouple is a temperature transducer that develops an EMF, which is a function of a temperature between hot junction and a cold junction. Here you can see a thermocouple. It can be constructed by using two wires. You can see the wire A and wire B. Okay, so It consists of two wires of different metals. A and B are different metals and which are twisted and welded together. That means end of each wire is twisted and welded together with each wire covered with an insulation. Okay, so at the end of A and B are joined at the both end. And when these two conductors of dissimilar metals A and B are joined together to form a loop, now it become a closed loop. Okay. And two unequal temperatures T1 and T2 are interposed at two junctions. Just take this temperature T1 at junction J1 and temperature T2 at junction J2. Okay, respectively. So we can measure the this. That means according to the working principle of this thermocouple, it will provide an EMF on this loop. So when we connect a voltmeter within this loop, you can measure an electromotive force by using that voltmeter, and that will be proportional to the temperature change in this two junctions. Okay, that means the working principle of a thermocouple. Thermocouple means constructionally it is a simple construction. It consists of two different metallic wires A and B, which are connected together at both ends. And if we are giving two different temperature at two junctions, it will provide an EMF on that loop. When we connect a voltmeter across it, we can measure an electromotive force, or if we connect an ammeter across on this loop, what happens? It will read a current because it's a closed loop. So that electromotive force will provide a current to flow through this loop. Okay. So that means when two conductors of dissimilar metals A and B are joined together to form a loop, and two unequal temperatures T1 and T2 are are provided on two junctions J1 and J2, then the infinite resistance, when we connect an infinite resistance voltmeter across it, it will detect an electromotive force. Or if we connect a ammeter within this loop, the current flow I can be measured. That is the working principle of a thermocouple. Okay, so this is a thermocouple arrangement. You can see the junctions. These are the two ends of thermocouple. The first wire is chromal and the second wire is alumel. Okay, chromal alumel combination. So you can see a chromal and alumel wire combination. So these two different metals are joined at these two ends, and a voltmeter is connected across it. And one junction is kept as a reference junction. That means we know the temperature of this reference junction, or we kept it is at a zero temperature or a particular temperature or atmospheric temperature. Okay, so which is a known temperature, that is the reference junction. And the other junction, we put that other junction on the measuring medium, that is the measuring junction. Okay, so now both the temperature become different. We know that according to the principle of thermocouple, when the temperature at each end of or each junction is different, then it will produce an EMF across that loop. So the voltmeter will read an electromotive force which corresponds to the change in temperature at these two junctions. And the working principle of the thermocouple is explained by using three effects, that is Seebeck effect, and next one is Peltier effect and Thomson effect. Okay, so by using these three effects, we can explain the working principle of this thermocouple. Okay, and the Seebeck effect, what is Seebeck effect? Which states that voltage produced in a thermocouple is proportional to the temperature between the two junctions. So that is invented by Seebeck in 1821. So it states that Seebeck effect states that the voltage produced in a thermocouple is proportional to the temperature between two junctions. Okay, so for example, if the temperature at one junction You can see at one junction is T1 and another junction is T2. Then the voltage is proportional to T1 minus T2, or voltage is equal to alpha into T1 minus T2. And this alpha is a constant which is known as Seebeck coefficient. So it is a constant of proportionality. Okay. So when we connect two different metals and the two junctions are joined together, and when we kept these two junctions at a different temperature, it will provide a voltage. That is the working principle of our thermocouple, and which will be explained by using three effects. That is first one is Seebeck effect. Seebeck effect is which states that the voltage produced in a thermocouple is proportional to the temperature between the two junctions. Okay. And another one is Peltier effect. Peltier effect states that we know that when a closed loop, within a closed loop, if there is an EMF, then that EMF will provide a current through that closed loop. So the Peltier effect states that if a current flows through a thermocouple, then one junction is heated up and the other junction become cooled down. That means one junction emits energy and the other junction absorbs energy. So that is the Peltier effect. So the Peltier effect says that if a current flows through in a thermocouple, one junction become heated up and another junction become cooled down. Okay. And the Thomson effect states that the junction EMF may be slightly changed if a temperature gradient exists along either both material. അതായത് നമ്മളൊരു സർക്യൂട്ടിൽ ഒരു തെർമോകപ്പിൾ സർക്യൂട്ടിൽ when there is a current flow, there will be a change in junction EMF. That Thomson effect states that the junction EMF may be slightly changed if there is a temperature difference exists. So we know that there is a temperature existence effect. So that change in voltage will be proportional to our difference variation of temperature. Okay. So when we kept one junction of the thermocouple at a medium whose temperature is to be measured, there will be a change in voltage in that thermocouple, and that change in voltage produced in that thermocouple is directly proportional to the temperature whose temperature is to be measured, or the junction which is in physical contact with the medium. So that temperature can be directly converted as a voltage by using thermocouple. So thermocouple എന്ന് പറയുന്നത് ജസ്റ്റ് കോമ്പിനേഷൻ ഓഫ് രണ്ട് രണ്ട് മെറ്റാലിക് വയേഴ്സ് ആണ്. രണ്ട് ഡിഫറെൻറ്റ് മെറ്റൽസിനെ എടുത്ത് രണ്ട് എൻഡ് ജോയിൻ ചെയ്ത് കഴിഞ്ഞാൽ അതൊരു തെർമോകപ്പിളായി. പക്ഷെ ആ രണ്ട് ജംഗ്ഷനിൽ ഒരു ജംഗ്ഷൻ നമ്മൾ റെഫറൻസ് ആയിട്ട് വെക്കും. അടുത്ത ജംഗ്ഷൻ യൂസ് ചെയ്തിട്ട് നമ്മൾ മെഷർ ചെയ്യേണ്ട ടെമ്പറേച്ചർ മീഡിയത്തിൽ പ്ലേസ് ചെയ്യും. ഒരു ജംഗ്ഷന് നമുക്ക് മെഷർ ചെയ്യേണ്ട ടെമ്പറേച്ചർ മീഡിയത്തിൽ പ്ലേസ് ചെയ്യാം, ഒരു ജംഗ്ഷൻ നമ്മളൊരു കോൺസ്റ്റന്റ് ടെമ്പറേച്ചറിൽ കീപ്പ് ചെയ്യുകയും ചെയ്യും. അപ്പോൾ ഒരു ജംഗ്ഷന്റെ ടെമ്പറേച്ചർ കോൺസ്റ്റന്റ് ആണ്. മെഷറിംഗ് ടെമ്പറേച്ചറിൽ പ്ലേസ് ചെയ്തിരിക്കുന്ന ജംഗ്ഷന്റെ ടെമ്പറേച്ചറിനനുസരിച്ച് ആ ഒരു തെർമോകപ്പിളിൽ ഒരു ഇ എം എഫ് പ്രൊഡ്യൂസ് ചെയ്യും. സോ ദാറ്റ് ഇ എം എഫ് ഇസ് ഡയറക്ട്ലി പ്രൊപ്പോർഷണൽ ടു ദാറ്റ് മെഷറിംഗ് ടെമ്പറേച്ചർ. ഓക്കെ, ദാറ്റ് ഇസ് തെർമോകപ്പിൾ. And okay, something. So now we are going to study about some another equipment such as RTD and thermistors. So in electrical temperature measuring method, there are different types of instruments. First one is thermocouple and another one is resistance temperature detector and thermistor. And mainly in electrical measurement, temperature measurement, mainly it works on the principle of basic principle of a conductor. We know that, just simply I can say that we know that the materials are classified into mainly into three, which are the main classifications: conductors, insulators and semiconductors. So for conductors and semiconductors, there is a basic property: its resistance will change with respect to the change in temperature. The metal exhibited temperature property as a positive temperature coefficient. That means when the temperature increases, the metal resistance will increases. The resistance of the metals will increase with the increase in temperature. Okay, so metals exhibit a positive temperature coefficient. So the temperature measuring instrument which is constructed by metals is known as resistance temperature detector or metallic resistance thermometer or RTD. So electrical resistance thermometers are of two types, RTD and thermocouple, RTD and thermistors, three types. Okay, then we have studied the thermocouples and the another one is RTD which is constructed by using metals, and metal have a property that its resistance increases with the increase in temperature. And the another one is thermistor. The resistance of semiconductor materials generally decreases with the increase in temperature. So thermosensitive resistors like semiconductors which provide a negative temperature characteristics. So it is also known as NTC thermistors, negative temperature coefficient thermistors. So temperature measuring instruments which is constructed by using semiconductors is known as thermistors, and temperature measuring instrument which is constructed by using metals is known as RTD. So NTC thermistors means which is constructed by semiconductors, and RTD is which is constructed by metals. Okay. And first I am going to explain about RTD. Okay. So RTD is a mainly it is just a thin wire which is made up of either by platinum, copper, tungsten, and nickel. Okay, for example, platinum, copper, tungsten, and nickel we are using as a RTD. These metals exhibit a small increase in resistance as the temperature increases because they have positive temperature coefficient of resistance. So platinum, copper, tungsten and nickel are the metals which is used to construct RTD, and these metals exhibit a property that a small increase in resistance will be provided by increase in temperature. Okay, most commonly used one is platinum wire because platinum is a it has a high operating range from 4 Kelvin to 1064 degrees Celsius. So commonly we use platinum as an RTD because it provides extremely reproducible output. Okay. For the measurement of lower temperature, we use nickel to make RTD. So for lower temperature measurement up to 600 degrees Celsius, we use nickel to construct an RTD. And we use copper wires to construct an RTD to measure up to a temperature range below 300 degrees Celsius. To measure a temperature range below 300 degrees Celsius, we use copper wires. And if we want to measure a temperature above 300 to 600 degrees Celsius, we use nickel. And most commonly used one is platinum wires because it can measure from 4 Kelvin to 1064 degrees Celsius. Okay, so now I just explained the construction of this RTD. Okay, so now you can see this one is construction of RTD, in which a wire of metal is wound on a you can see just a wire of metal is wound on a grooved hollow insulating ceramic former. Okay, you can see here just a wire of metal which is wound on a grooved hollow ceramic former and which is covered with a protective cement. Okay, a protective casing is provided for mechanical protection, and the ends of the coil, these ends of the coil are welded to a copper leads and which are taken out, that is on copper or platinum leads. Okay, we can take two ends of this platinum wire out of this casing. Why we are taking the two ends? because to measure the temperature, we have to connect these two ends or these two leads as an arm of the Wheatstone bridge circuit. In some cases, this arrangement can be used directly in the medium whose temperature is to be measured. So sometimes we have to place this RTD in a medium whose temperature is to be measured. So we can get a fast response. That means we can get the fast output in the Wheatstone bridge. Okay, so the end of this RTD is connected as a one arm of a Wheatstone bridge. So the change in temperature will produce a change in resistance of this platinum wire, and that change in resistance will provide an output voltage in a Wheatstone bridge arrangement. And the voltage produced, change in voltage produced in that Wheatstone bridge arrangement is directly proportional to the temperature of the medium. Okay, so in most applications, a protective metal sheath is used to provide rigidity or mechanical strength for this RTD. A protective metal sheath is used to provide more rigidity and mechanical strength. Okay, so mainly platinum, nickel and copper are used as a RTD. So we know that commonly we use platinum because there are some advantages for using platinum wires because platinum has high temperature resistance characteristics. Okay, it has a wide range of temperature resistance characteristics, and it has high resistance to chemical attack, and also it can easily reproducible type of temperature transducer and high accuracy. It will provide high accuracy. Okay, so these are the platinum wire RTD, and it can also constructed as a thin film. Okay, and these are some other. And the next one is thermistors. Okay, we know that thermistor is a semiconductor resistance sensor. Okay, thermistors are thermally sensitive variable resistor made of ceramic like semiconducting material. Okay, thermistor responds negatively to the temperature. I have already told that when temperature increases, resistance property of the semiconductor will decreases. That means it responds negatively to the temperature. So it is known as NTC thermistors. Okay. Then that means they are manufactured from semiconducting materials. These are the thermistors which are manufactured from semiconducting materials, which include the oxides of copper, manganese, nickel, cobalt, and lithium. And these oxides are mixed to a suitable proportion. The construction, I am just explaining the construction of thermistor. To construct a thermistor, we have to mix a combination of oxides of copper, manganese, nickel, cobalt and lithium, and these oxides are mixed together in a suitable proportion and compressed into a desired shape. Hmm? Either it may be a bead shape or disc shape or rod shape. Okay, by mixing this combination and mixed it to a suitable proportion and which is compressed to a desired shape and from the powders, and it will be placed or heat treated to recrystallize them and resulting in a dense ceramic body and which required a resistance temperature characteristics. Okay, that means construction എന്ന് വെച്ചാൽ തെർമിസ്റ്റർ എങ്ങനെയാ കൺസ്ട്രക്ട് ചെയ്യാന്ന് വെച്ചാൽ ജസ്റ്റ് ഒരു ഒരു സ്യൂട്ടബിൾ പ്രപ്പോർഷനിൽ ഓക്സൈഡ്സ് ഓഫ് കോപ്പറും മാംഗനീസ് നിക്കൽ കൊബാൾട്ട് ലിഥിയം ഇത്രയും എലമെന്റ്സിന് സെമി കണ്ടക്ടിങ് എലമെന്റ്സിനെ ഒന്നിച്ച് മിക്സ് ചെയ്ത് ബ്ലെൻഡ് ചെയ്ത് അതിനൊരു സ്യൂട്ടബിൾ പ്രപ്പോർഷനിൽ കംപ്രസ് ചെയ്ത് ഒരു പെർട്ടിക്കുലർ ഡിസൈഡ് ഷേപ്പിലോട്ട് മാറ്റും. ഈ ഡിസൈഡ് ഷേപ്പിലോട്ട് മാറ്റിയിട്ട് അതിനെ ഹീറ്റ് ട്രീറ്റ് ചെയ്യും. ഹീറ്റ് ട്രീറ്റ്മെന്റ് കൊടുത്തു കഴിഞ്ഞാൽ ഇറ്റ് ക്യാൻ റീക്രിസ്റ്റലൈസ് ദം ആൻഡ് റിസൾട്ടിങ് ഇൻ എ ഡെൻസ് സെറാമിക് ബോഡി ആയിട്ട് മാറും. ഐദർ ഇൻ എ ബീഡ് ഷേപ്പ്, ഡിസ്ക് ഷേപ്പ്, റോഡ് ഷേപ്പ്. ഈ 3 ഷേപ്പിലാണ് പൊതുവെ സെമി തെർമിസ്റ്റേഴ്സിനെ കൺസ്ട്രക്ട് ചെയ്യുക. ഓക്കെ, by after heat treatment you will get a bead type or disc type or rod type thermistor. When we place this semiconducting material or this thermistor on a temperature medium and the two leads are taken out of this semiconductor medium. The solid, which solid portion, bead type solid in construction ആണ് ഞാനിപ്പോൾ പറഞ്ഞത്. ജസ്റ്റ് നമ്മളൊരു പെർട്ടിക്കുലർ suitable proportionൽ കോപ്പർ, മാംഗനീസ്, നിക്കൽ, കൊബാൾട്ട്, ലിഥിയം ഓക്സൈഡ്സ് എല്ലാം കൂടെ മിക്സ് ചെയ്ത് ഒരു suitable proportion ഒരു റീക്രിസ്റ്റലൈസ് ചെയ്തൊരു സോളിഡിനെ manufacture ചെയ്യും by heat treatment. Then we take 2 leads out of this thermistors, and by connecting these leads as a one arm of the Wheatstone bridge, we can measure the temperature, or we can convert the temperature to a voltage. അതായത് നമുക്ക് മെഷർ ചെയ്യേണ്ട ടെമ്പറേച്ചർ മീഡിയത്തിൽ we have to place this thermistor on physical contact with the temperature medium. Then by connecting these leads, outer leads to as the one arm of the Wheatstone bridge, we can measure the voltage change in Wheatstone bridge, which is proportional to the temperature whose temperature is to be measured. Okay. So these are the different electrical temperature measuring devices. Another method is radiation method. I'll explain an radiation method in the next class. Okay.